Thank you, everybody. My name is Anthony Vandenberg, Lake Oswego School District in Oregon. We're a small school district, about 10 miles south of Portland. That's me. We have a beautiful community, a little lake, 7,000 students approximately. We've got 7 neighborhood elementary schools, 2 middle schools, 2 high schools, 1 community transition program for our adult learners up to age 21, 95% graduation rate, 57 spoken languages, and we're an A+ niche grade rating. #1 school district in Oregon. Take pride in that. Capital improvement programs, that's what I do. I don't claim to be an educator, I'm a builder by trade. But over the years, I've focused on K12 educational facilities. It is my passion. I feel like these buildings are dynamic, they're different, and it's always evolving. Our capital improvement programs really started in 2015. The start of it looked at the long-range facilities planning. What are we going to do in 5 or 10 years? The first one was easy. We hadn't worked on these facilities for 20 years or more. The vintage of the schools were 40s, 60s, late 90s. Some of them in incredibly poor shape. One of our schools was situated on expansive soil, which means that every time it rained, the ground moved. We had cracks in the walls. This building was unsafe. We set out to form a bond program. We worked with the community to find out what was important. What did we want to do for these new schools? What did we want to do to improve our schools that matched our educational excellence? So we started to look at guiding principles. The community brought forward sustainability at the forefront of everything we were going to do. It was going to influence all of our decisions. We're going to work to reduce the impact on the environment. And this is going to create schools that were going to act as a teaching tool as well. Provide gardens and outdoor learning opportunities. You know, it rains in Oregon quite a bit. Covered outdoor classrooms are a thing. Maximize daylighting, big, beautiful windows. Prioritize the life cycle of our systems. Reduce the energy consumption. Embrace renewable energy at the schools. All buildings that are new will be 100% electric. We're going to move away from fossil fuel. Enroll into a Path to Net Zero program through the Energy Trust of Oregon. Also brings us incentives. All buildings and retrofits, remember, resilience is on top of mind with this school that was failing. These buildings will be designed to seismic level 4, allowing for immediate occupancy. Not only the buildings, but the equipment inside of those buildings. So now we're going to take a step back to 2020. I'm sure this is going to be hard for some people. It is for me, remembering these dark times. We're in the middle of our first program, the first of 3 that we had contemplated. We were building a brand new middle school, state-of-the-art middle school, nothing that this school district had ever seen. New learning environments, shared learning classrooms where paired teaching could happen, an inner courtyard, safe and secure campus, 100% electric, seismic level 4. We ended up building sustainability meets resilience. I like to look at this as more like sustainability is resilience. This building is super insulated, triple pane windows, 100% electric, again, PV on the roof, hybrid passive was what we chose for our approach to the mechanical. Maximizing daylight, of course, it was Path to Net Zero. The PV array on the roof, 100% electric, seismic level 4. a backup generator for the critical loads. Now, one of the things that the community kept saying to us is, what are we going to do if there's a major earthquake? The big one is bound to happen on the West Coast in Oregon. It's 100 years overdue. Any minute now, it's going to shake. So we had to start thinking about our buildings. What are we going to do to get the kids back into school, to get their parents back out into the workforce, and to keep education moving forward? Backup generator is a diesel generator with a 3-day runtime. The robust building envelope allows us to keep the building comfortable. The temperatures in Oregon rarely dip down below freezing for a sustained period of time. The building is super insulated. We've got R50 on the roof, R30 in the walls. Now that's not where I grew up in the Midwest. In Chicago, it's probably not going to be that great when the power goes out and the heating plant goes down. But here, it's still really comfortable. So we actually finished that school. This is what it looks like. Brand new middle school. We were on top of the world. We were feeling great. The community was excited, energized. We were looking at our second phase. What are we going to do for this next bond? The first bond was focusing on stopping the hemorrhaging, fixing our schools, all the leaks, all the single pane glass, the technology. We did that. So in 2020, February, we started educational adequacy assessments of our elementary schools. We were poised to start building new elementary schools now. We had 3 elementary schools that were in need of replacement. The first one was River Grove Elementary School. And then the pandemic. It made my commute fantastic. We put our heads down and we continued pre-design. We started thinking about, what are we going to do differently? We knocked it out of the park with this first school. Now, what else can we do? Keep the momentum, keep the community energized and with us. This is the second phase of our bond programs. This one was going to raise taxes also. So we wanted to get to a place where we could have renewable bonds. We didn't have to renew taxes each time and go for an ask. So this is the second phase. We had wildfires. This is September of 2020. We were starting this pre-design, and now we have wildfires. The hybrid passive design may not be the best idea for our future schools, where you're drawing in outside air and bringing it up through the roof to cool your building, to clean your building, and bring in this fresh, beautiful air that we're very used to in the Pacific Northwest, all of the trees surrounding us. We burned 1 million acres during this season of wildfires. This is a picture I took on my way home. You can see Portland on the map. The green is, you're okay, but you ought to pay attention. Yellow is you start packing up your personal belongings. The red, get ready to evacuate. The really dark colors you see there are actual fires that were occurring in real time. This is incredibly close to home. Never before have we experienced this. Usually we're out in the mountains down to the south. This is very, very close. So all of this is top of mind. We were in full design, and suddenly a massive ice storm. When we have ice storms, it's not like what we're used to, where I grew up in the Midwest. We have trucks that deploy salt. We have plows. We don't have that in Portland. When it snows, a half an inch, the city shuts down. This is about 6 inches and about 2 inches of ice. So freezing rain started to drop our electrical lines. We dropped trees. In the city of Lake Oswego, we lost 250 Douglas fir trees. Douglas fir trees are large trees, 120 feet tall. They average 100 to 120. So we started full-on design with all of these things in mind. Our guiding principles for the new school, safe and welcoming for all. You see a lot of these things repeated from our guiding principles of the bond program. Access to the outdoors, a gathering place for a community, not only for gathering for events, but gathering for during an emergency, a place of refuge. Inquiry, spirit of innovation, and of course, sustainability and resilience. If that weren't enough, in June of 21, we had a heat wave. The Great Pacific Northwest Heat Dome. We had temperatures of 116. We're not built for that at all. A lot of the buildings, a lot of the homes, they don't have insulation, they don't have air conditioning. We don't need it. We open windows. We get this beautiful, cool air at night coming down from the mountains. Summers are 80 and sunny. It's beautiful every day. It's not like here in the summer at all. Again, the hottest recorded temperature in history, 116. We had 3 days that were well over 100 degrees. 69 people died in our county. House Bill 2021 passes, June of 21. This is interesting because it charged the electric utilities and others to think about reducing energy consumption. How are we going to do it? To me, I was thinking about incentives. This is going to bring a lot of incentives. Our utilities are now going to play with us. They're going to work with us on renewables. So we kept designing. Again, our design guiding principles matched what we were talking about in the beginning, in pre-design. So we started to think about a microgrid. Now, how is this going to be different than what we did the first time with our new school? We wanted to be energy efficient, highly sustainable. So we thought about this idea of a microgrid. Now, what is a microgrid? Well, you have your traditional utility, the macro utility, if you will. You have other renewables on site. PV is the traditional. You could use air, so wind generation. You add a microgrid controller, a programmable controller that can control all of these different energy sources into your building. You see the arrows here. I like this diagram for this reason because it shows you the in and out of energy and the disconnect. If the utility grid goes down, the programmable microgrid controller can utilize the other components. In our case, we weren't looking to power the entire building. We don't have that kind of money. But we wanted to do enough to create a place for the critical loads and the large common area spaces that could be used as a place of refuge to get us back up on our feet. Now, the modes of operation are fairly simple. Normal mode, you've got PV on the roof, you've got utility coming in, everything's kind of okay. You're operating slightly reduced load because of the solar. You go into emergency mode when you start getting into brownout situations, somewhat frequent drops of power, systems turn on, you have a generator, you've got PV, and you've got a battery. That's the key. To get into fully island mode, we're completely off of the grid. You're islanded. No grid exists. So the winter storm, people were without power for up to 3 weeks in the city. They were still responding to the fires down in California, in Southern Oregon, and elsewhere. So this became really important for us. How are we going to sustain keeping our buildings open? And then we started thinking about, well, what about budget cuts? I started losing my maintenance staff, my operations staff, because we don't have funding from the state. It's volatile. It could be more volatile in the future. Spending less money on operating a building, energy, can go to staff, as an example. Emission reduction can happen with a microgrid as well. And when it becomes grid interactive, it's a whole nother ballgame. This is essentially what we have at the site. Our programmable microgrid, 150 kilowatt PV system on the roof, 150 watt battery storage, and a diesel generator, also 150 watt with a 3-day fuel tank. Now, all of these things can be working together. So if the grid goes down and you're in a nice sunny day, you're still collecting from the PV. You can store in the battery or discharge the battery. You can run a generator. Now, this is the thing that really caught my eye. The utility has been sticking it to us for a long time. We pay more in the middle of the day. And when I started to think about this, I understand why. And I don't dislike the utilities that much, maybe a little bit. But they have to fire more fuels, fossil fuels, often. The plants ramp up, they deploy energy. We thought we were saving energy with building these new sustainable buildings. We're actually spending a lot more on electricity. Every classroom has 2 wireless access points. Every student has a device they plug in every single day. Every classroom has 2 monitors instead of 1. We're using a lot more energy. So when you look at this, in the morning, you can see how we're using grid energy. It ramps up. PV starts to really become efficient midday. We start to discharge our battery. We can even feed back into the grid. A typical building on the left here, you can see a big peak. We've got this big curve in the middle of the day. That's when we're most inefficient. We're using the most energy. An energy efficient building, a super insulated building, everything is LED lights, all of the other things that we do. You can see the curve gets smaller. This is a very exaggerated, the next one with the PV, but a massive PV system, you can see how we begin to inverse. That curve essentially goes away. When you add a battery, and this is key, and this is what you want to do, you want to flatten that curve and make it more predictable. And if you can do that with a grid interactive building, you have energy efficiency, you've got your solar array, and now you have battery backup and a generator. This is what the building ultimately looks like. Brand new River Grove Elementary School. I like to refer to it as the Pincy Beetle. 2 classroom wings off to the edges, hugging the beautiful forest. Entry in the top, separated parent drop-off and bus drop-off, always important. Back of the house, you see the battery storage, the generator, incoming power, and PV on the roof. Of course, outdoor classrooms, play areas. I love this picture because it's our switchgear, our cool microgrid. So this is the thing that makes me excited. So you can see our switchgear in our really clean electrical room. Our mechanical room has about 3 pieces of equipment, a couple of water heaters, a couple of condensing coolers. That's about it. This thing's packed full. On the right-hand side is the actual microgrid controller. You can see our curve of energy use. See it spiking in the middle there. And here's the school. You can see some of our beautiful Douglas fir trees from before, during construction. This building is mostly timber. We have some tilt-up concrete. Again, we rely on building mass to help cool our building. We actually completed it, and this is what the building looks like at the end. But I want to go back to some of the challenges. Relatively new technology, although it's not really. It's still a challenge. Working with the utilities is an incredible challenge. We first approached our utility about the notion of a microgrid. we were looking at a much larger battery. I wanted to feed back into the grid. I wanted to sell them energy for more than they were charging me for it. The first thing they told me was, that's not necessarily how it works. Okay. They also told me that given the existing utility coming to the site, that it wasn't possible for me to feed back into the grid. They would have to upgrade their conductors all the way back to the substation. Okay. Well, we're going to keep it on site then. Our system is a relatively small system, and it's going to teach us a lot of things in this first year. We're going to see what peak shaving looks like. We're going to try to keep it as not complicated as possible. And we're going to see what the maintenance looks like. If we keep doing things like this, we have a future. We've got our staff, and we have these beautiful buildings. Thank you.
Thank you so much. Let's hear it for Anthony one more time.